Hello, this is Dr. Lennon, and we are going to do the quadratic regression model for a nonlinear relationship to see an example of that. So we're going to use the web file Reynolds, and basically I'm going to show you how to do the quadratic regression model in two ways. So this is the example in the textbook on that starts on page 165. So if we want to do it with the old-fashioned scatter plot way, what we can do is we can just select all our data. We have months employed as our X value and scale sold as our Y value at this company Reynolds. And if we select that and then click Insert, we can just click Scatter, and we get our scatter plot. On the quiz, I asked you to do this and do two lines, the linear line that we did in the previous video and now the quadratic one. So I'll just show you how to do the quadratic one. So what you want to do is just right-click on a data point and click Add Trendline. And linear, notice that's what we were doing before. Now what we can do is we can actually click polynomial, because a quadratic equation is just a polynomial in degree 2, and change the order to 2. So that 2 means degree 2, so quadratic. And then if we want to see the actual equation and the R value, remember to click those two so we see it. I'm not going to display the R value right now, just the equation so we can see. So there we go, and you're going to want to move the equation just over to the side so you can see it. So notice that this data doesn't, it looks like it starts to decrease once we get around this x equals 80 mark and flatten off. So in this case, a quadratic model, if you would compare it to a linear one, turns out to be a little bit better. And that if you actually display the R value, it'll show it to you. And then we have our two parameters, our beta 2 parameter and our beta 1 parameter. And then our constant value. So that is how to do it using the graphical way. If you want to see it using the multiple regression method, what we're going to do, let me just delete this, so I'm going to get rid of the chart. What we're going to do is, notice we have our X value and our Y value, but what we're going to need to do is insert a third column. So I'm going to click Insert, and then notice the quadratic equation is an equation based on x and x squared. So I'm going to add a new column here and call it months squared. And what I'm going to do is I'm just going to square all the x values here. So I'm going to hit equals for formula. I'm going to click the one right to the left of it and then do a little caret and square. So if you hit shift and 6, it gives that caret, and it means raised to the power 2. So literally it's just going to square the number 41. So then I hit enter, and then if you highlight the cell again and click this little corner and drag it down to the bottom, it'll square all of them for you instead of you having to do it every single time. So now notice we have two columns of independent variables and one column of a dependent variable, or a Y variable. So we can go over to data and click the data analysis and use our multiple regression tool. We just have to select the right input range. So notice the Y range is right here, the X range is right here. Remember, if you include your first rows, click labels, confidence level, and just hit OK. Oh, I must have done something wrong. So my Y range should be right here. I forgot to move it over. And then the X range is just going to be these two columns. And then everything else is still the same. Let's click OK, see what we get. And if you notice, we get the same exact parameters that we saw when we had the scatter plot and we added the trend line. We have the negative 0.031. That's what's multiplied by x squared, because that is corresponding to months squared. 5.81, that's the months employed, and 61.42 is the constant value. And we have our F test here, and we have our corresponding p-values to the t-test for each parameter too. If you're ever asked to test whether there's an overall relationship with the data, we look at the F test, or testing if each of the values is 0. We're going to look at these two numbers. Notice they're both smaller than our significance level, so in all cases we'd again be rejecting the tests. So that is how you can do a nonlinear quadratic model whenever it looks like you might have some sort of bend in your graph, and a linear model might not be appropriate. So that should help you out with the quadratic question on the quiz. Okay, thanks. Good luck.